So we'll get the talk over with that I'm in. I already said who I was. I work on, Matt Storgerson, I work on C# for Microsoft. And
I'm Dustin Campbell. I work on C# as well. I work on the tooling side for C#. So we're kind of two sides of the same coin.
So we're going to quickly show you some of what's in store for C#, the language, the compiler, the tooling, the ecosystem for the next round of the next release that we're working on. And so the thing that's really been defining what we've been working on for C# for a long time is what we have called Project Roslyn, which is our attempt to finally step into the 21st century with our compiler technology. We've rebuilt compilers from scratch for C# and Visual Basic. In C# and Visual Basic, I know that's how other people have been doing it for a long time.
Yeah, we finally reached self-host.
Yeah. So we write the C# compiler in VB and the VB compiler in C#. Not. And this time around, it was really important for us to open up the sort of traditional black box Dragon Book compiler and turn it into something that has a rich public API so everybody can use it as a tool for reasoning about source code and producing source code and essentially have a segue into building your own language-based tools, plugins for Visual Studio or standalone tools or what have you, and get you that deep understanding of the language in an API that normally is more or less reserved for the compiler or for some closed stack that is proprietary. So we did all that, and we put that compiler code base out on Codeplex as open source, take contributions. We would love for academics to pick it up and use it as an example of, either this is how compiler should really be done, or this is how you absolutely should never do a compiler, depending on what you think. So that's the kind of change we're looking at. And the way we call this API the .NET Compiler Platform because at Microsoft we need long names.
It took us a while to just get them to not put Microsoft in the title.
We had many meetings and emails and crises.
Microsoft.NET Compiler Platform 2014.
Getting to that point. Yeah. So it's a .NET Compiler Platform. It's got nothing. It doesn't have C# in the name. So why are we undertaking this effort? Well, a lot of it is actually just getting to where we can build better tool support. Like we've sort of reached the limits of how you can get that nice live feedback in the tool, unless we get better support in the underlying sort of the language understanding. So we really needed that better thing. Like for the millions of developers out there, get to the next level of toolness, coolness, we kind of needed that revamp. And then, as I said, opening up as an API, hopefully we no longer have a patent on building tools and support and giving people an experience. Hopefully we'll have an ecosystem of people who will do like their own diagnostics, their own refactorings and stuff like that, offer them up to each other, implement company-specific rules just within the company or whatever. It's no longer up to us to build something that's one size fits all and we will never get around to all of it. So again, it can benefit the millions of developers indirectly. And then just for ourselves, having a better code base to work on means it's easier for us to make new language features and get things working and so on. So that's kind of the thing. And then by opening it up, making it open source, I think we're sort of just improving the impact of that even further. And so it's a new experience for us being open source. It's a new experience for Microsoft as such.
Yeah, we did that beginning of April, last April. We open sourced C#.
We just opened it up. And man, do people have many complaints when they can see how the sausage is made. So that's kind of interesting. But so what we're going to do today is mostly we'll go into demo mode. So Dustin will talk some about actually showcase some of these APIs and like kind of just give the feel for how easy it is, how normal people can use language APIs and get interesting stuff done. Yeah. And we'll show a little of some of the new language features we're brewing on to build on top of this. And our 40 minutes will be long gone. Yeah. So I'm going to switch over to you.
Yeah, we're kind of going in rapid pace mode. I'm going to talk a little bit about kind of using Roslyn and using the .NET Compiler Platform, the Roslyn. We still call it Roslyn, right? But just that public API surface in the compiler for building kind of cool things, useful things in your source code on the tooling side. I find myself really fascinated by tooling in particular. I like writing compilers, but compilers are kind of easy, right? Because the code's always correct. And it doesn't really need to operate unless it just needs to just print errors if the code's not correct. But the tooling has to work every time the code is broken. When I press dot, my program doesn't compile, but I still need to show meaningful information, right, to help. And so that idea of coupling semantics and static typing and kind of the knowledge of a compiler with heuristics is something that I really get into. And so I want to talk about some of that and kind of really where you can use this API to kind of plug into the tooling. So I've got a program that I use for my own, my own selfishness. I like to show this program. It's actually written in F#, C#, and Visual Basic, just because it's a great demo. And it's something that, for this room, I think in particular, it's a slightly nerdier room. It's a Z machine, right? It's actually a JIT compiler for this, but it works. It's actually running Zork. I can open the mailbox. I can get the leaflet. I can read the leaflet, right? And you can see it's really Zork 1, right? Even cooler, but I don't like to do that. I like to show off that we can just run Zork from beginning to end. So this is the code base I'm just going to use to kind of play around with on tooling, and that screen really makes that really run even faster. Cool, Master Adventurer, excellent. All right. Perfect score. So I was perusing through this code base, and I saw this block of code. Now, I can't fool this room, but when I've given this demo before, definitely people are confused by this piece of code. They assume the else block goes with the outer if, right? It doesn't. Everybody in this room knows that, yes, it goes with the inner if. But this is the reason that say I'm in an enterprise, I'm on a team, why I would say we're going to have a coding standard that, yes, I want to use curly braces on every if, on every else, and make sure that things balance out right. Because if I format it in the editor, you're going to see that, of course, it's wrong. And so this is the sort of thing that we put static tools into our tool chain for. We have things that kind of, we build big make files of lots of extra tools to run to give us guidance on these sorts of things. We run style cops. We believe this is the sort of thing that should not go in the compiler per se. The compiler shouldn't be in the business of making these sorts of decisions and reporting errors on these sorts of cases. But there's sorts of things that should run in the compiler. Okay? If I want to build a static analysis tool, it seems very silly for me to then have to, and inefficient in some way, to go ahead and write that static analysis tool after compilation. It should happen during compilation. It should happen while the compiler is actually doing the parsing. Come and ask me, are there diagnostics here I should be reporting? And so one of the key pieces of Roslyn that we're doing is a framework for doing diagnostics, for building diagnostics that run at compile time. They run in the editor as well. So we could build a diagnostic that does this. And I'm just going to kind of have it pre-built because I'm racing through a little bit so we can get to some of Mad's goodness. But this is what that would look like. All right. There's a little bit of boilerplate up here, but the meat of it's right down here, where I'm given pieces of the API, objects coming from the model that the compiler itself, the C# compiler, uses during compilation, right? And so I can, analyze a node. It comes in. Is this an if statement node? Does it have braces, or does it have a statement at all? Is that a statement itself actually a block? And if not, go ahead and add a diagnostic, right? And the same thing with an else clause. It's very simple to do. Okay. Now, along with that, I can write a code fix. And the code fix provider, this would result in a squiggle in the editor. It would result in the command line build reporting diagnostics. And it's a very simple syntactic one. You have the core kind of fundamental components here that would allow you to do something a little more interesting, a little more, with a little bit more semantic analysis as well. But this is kind of a simple one. Now, the fix itself looks sort of like this. The objects in the compiler, in the Roslyn API, are immutable. And this that builds up trees that are immutable. And then so when you want to make a change to introduce some code fix or some transformation in the source code, you do that by making a change to the abstract syntax tree, getting back a new tree, and pushing it back into the compiler. And so that's what we've done here. We grab the if statement syntax. We create a new statement, if statement syntax, with a brand new statement. Okay, and the way that looks, that statement is a block containing the original statement. Okay, and so this way we add braces to it. Now, one of the cool things here is this guy. This applies a formatting annotation to that, so that when the transformation engine happens, when we call the code action engine, applies this transformation, it's going to see that that node has a little annotation on it that says, this is a formatable node. So that it will, in my environment, whether that's in Visual Studio or something else, whatever my settings are for braces, do I want them to be that opening curly to be at the beginning of the previous line? Do I want it to be on a new line? That will happen automatically. You'll get it formatted with the rules of the IDE. Right? So then we replace that if statement node with the new if statement we just created, and then we return a code action. And so I'm just going to run this guy. It actually runs in another instance of Visual Studio. So I'm in Visual Studio, loaded in Visual Studio. We'll open up that same code base. And this time, as the analysis happens and it finishes up in the IDE and the editor starts highlighting, there are little green squiggles, right, on the ifs and the elses. And those green squiggles are exact, say that, yes, if statements must have braces. Else must have braces as well. But the cool thing is that there's also this code fix. And so I can bring up this code fix. And you see right here, it goes ahead and does that. Now, what I really like about the immutability of the Roslyn API, that allows us to do things with, in asynchronous ways, concurrent ways in the IDE, where we want the IDE, the typing to be responsive. Right? We don't want to be the worst thing in the world when you're writing tooling is that when you press that dot in whatever language or whatever equivalent operator is to go compute the entire symbol table and figure out what you should be showing there right now on the UI thread. That's a bad idea. That will eventually your user's library space will grow such that that's not a good plan. And so we've done a lot of work to make this Roslyn immutability to make sure that every IDE feature is asynchronous. And this is one of those where asynchronously we kind of compute a new tree, right? We compute a new model, a new kind of universe, and then we give the user an opportunity. Do you want to apply this back? And because we have this entire model of the universe, we can run all the language features on it inside this little window. This is like a window kind of into the future. It's not a preview. It's not like some sort of thing we concocted in the code fix. It's just, here's the transform tree. Show me what that would look like in another editor embedded inside of here. Right? And as I said, that formatting annotation, go back up here. I'm going to change an option. Deeply nested. Holy crap. All right.
You're being recorded.
I am. My manager won't watch this, will he? All right, for control blocks. So if I say I wanted my braces to be on the other line, well, now that shows up here, right? And the nice thing then, of course, is that you'll also notice that as I apply this, it automatically corrects its indentation and everything and does the right things. So it's really easy to go and write diagnostics that kind of run not just in the editor, but also in kind of within the compiler as it's doing its analysis. What's also awesome about this, or where we plan to take it, is we want this to kind of, our vision is to have this go along with APIs, right? You can imagine an API adding a reference to a library, and it comes along with its own diagnostics, right? To report diagnostics, report errors and warnings for its own semantics, not just for broken code the compiler knows about. A good example might be a regular expression library, where the library itself comes along with a diagnostic analyzer that might report that the regular expression was incorrect. Maybe offer a code fix to fix it, to actually look at the string literal and fix that for you. So there's a lot of interesting opportunities there. Yeah?
So could the analysis use white space? Because the white space is just a different attribution of the else. Like
I'm sorry.
Yes, it can.
Yes, it can. So, all right. So with that, I want to step back. I want to let Mads take his opportunity to look at new language features. Sure. But that's kind of a quick look at a piece of Roslyn we feel is very core to the future of C#. Mads, let's move on.
Yeah. So, I just want to summarize here the idea of having. It was very core to us to have this idea of presenting a full immutable tree of the world to the user at any time through this API and making it efficient. The immutability gives the concurrency benefits and so on, and it makes it really safe to hand the sort of the core nuggets of the compiler knowledge to users that we don't know and we don't trust. Right? They can bang on this however much they want. It's immutable. They're not going to change anything on some different thread and get shared state issues or whatever like that. Of course, a lot of the work that we put into it has been making that efficient. When you are creating a new universe, every time you type, of course, there's plenty of persistent data structures and all kinds of nifty tricks in there, laziness and so on. Which hopefully, being open source, people will point out when we're not doing it well enough and stuff like that. But I think also, I think that's probably the point to make about it.
Yeah.
So if you guys want to. If you guys want to go and play with this, you can go here to msdn.microsoft.com, and you can download a preview on top of the current version of Visual Studio, and you can play with the new language features I'm going to show in a minute, the new IDE features that we built a complete IDE completely on top of this public API. Everything you see in our IDE experience, that was the other point I was going to make, is made on top of the public API so that we hold ourselves to our own standards. Right, we eat our own dog food all the way up. And you can go and look at CodePlex, which is this very vibrant site for open source that all the cool projects are at. This is where we keep the source code for the compiler. There's plenty of there is actually plenty of activity here. If you look at discussions, we post the C# language design notes up here as soon as they go up. You see, I posted this one. A couple of days ago, there's 23 people heckling me about how stupid we are, and in general there you can kind of follow the work. You can build your own.
Where's my favorite?
Where's
my favorite?
I don't know. What's your favorite?
Oh, it's not on top anymore.
Point out that heckling is real, and you have responded to it.
Yes.
Yeah. So
removing embarrassing features
in a properly open source fashion. We are actually responding to feedback where the language design and the other layers are changing in response to feedback at all levels. It's been a really great experience for us. I want to go now and show a few of the new language features we're planning to add. So I should say that the philosophy for the next version of C#, the language, is really disappointing. Okay. It's not where we have usually come up with some idea that we at least thought was bright and magnificent and huge and about to change the world, like doing query support or doing asynchronous support in the language and stuff like that. No, we think that Roslyn is a big thing in this release. What we want to do is to just make things a little nicer in a lot of places. So to kind of make everyday coding in C# a little nicer. So we've stolen a lot of features from other languages that we feel are nicer than C#, and we come up with a few funny ones of our own. And what I'm now going to admit to our crimes and kind of just show you all the things we've stolen. This first one's for Alex Buckley.
Yeah, bonus points if you can point to the person we stole it from.
A lot of times we have, where did Alex go? A lot of times we have, the original people in the room here. So one of the things that we want to allow is using static classes containing static so that those function members get directly in scope, and people who are, so system.console, system.math, things that have lots of nice static functions that people just want to call directly rather than having to prefix with a class all the time. Java has had this for years now, right? Fix all occurrences, and now we can just say write line, and you can call math.square root and stuff like that.
So one point I'd like to make here is that because we've actually, as part of Roslyn, not just rebuilt the compilers, but also rebuilt the IDEs and the tooling. And that's all built on public API surface that's exposed from the compiler. Because we've done that, when we implement something in the compiler, the tooling's almost already there, right? It's very small, the sorts of changes we need to go and make in the tooling when we add a new language feature. A lot of it's kind of already in place, which is a cool thing.
Right.
So I didn't do anything for this particular feature.
Right.
Yeah.
Another point to make about it is that other people can build their tooling for C#. Other people do have tooling for C#. They can build it on our code base. They don't need to reinvent the wheel. And actually, Xamarin announced that they will change their tooling over in time to build on our same code base. So we can kind of share the benefits. Hopefully, they will improve the code, and we'll make use of that. OK, next language feature. So first of all, this program does nothing interesting. It creates a list of points, writes them out, turns them into JSON using a great third-party library out there called JSON.net. Writes that out and turns them back into points using some functions that I have, right? So I don't even want to run it. But one of the, we've done a lot of programming with immutable types now with Roslyn and so on. And so what better motivation to put features in the language than to make them better for implementing the language, right? That's how all languages end up in this black hole of
our own pain more than
our own pain is really motivating. And honestly, today to build an immutable, like this simple point type here is pretty painful. You have to, you want to expose some public properties. You want to have backing fields for those. You want to initialize those backing fields with constructors. And we looked around and said, hey, who does cool stuff with this? And languages like Scala and F#, they just have great shorthands for this. I'm sure lots of other languages have them too, where you can just say, hey, I have a constructor that's my most important one, and I wanted to allow you to just pass those constructor arguments directly on the class. If you have a base class, you can just say, some other class here. You can just inheriting from console. You can just pass them along there directly, and just put them in scope for initialization. And so now I can just initialize my backing fields right here, and in this way, I don't even need a constructor. Right? I can just delete it. If I want some, you will notice that features are working here. That's because I'm using the preview I pointed to before. And if I go a little further, C# has this notion of auto properties already, properties that automatically have a backing field. And we can now extend that a little and say, I want myself a property that automatically has a backing field, and that backing field is initialized with X. And then I don't even need to express the backing field anymore. Do the same for Y, and all of a sudden, this is not just about reducing boilerplate. It's sort of about making the important parts of the class stand out and just make things terse and readable. This guy needs an X and a Y. It exposes a capital X, capital Y based on those X and Y. It can't be set much shorter if you want to still be case sensitive and have two different names for these things, which we haven't moved beyond that yet. We're still in sort of the C-style world here. So that's a set of features just for convenience, right? It's really just convenience. Let's see. What's another interesting thing that we can do? I want to mention some features that we haven't gotten to yet. We also want to reduce the overhead of. I think there's a lot of function bodies, method bodies, and property bodies and so on that really just have the shape of return something, return an expression. The more expression-oriented you get, the more you get into this situation where you just have this big curly return thingy here just to return the result of a simple expression. And we already have lambdas in the language that can have a body that's just an expression. Why not let methods also have bodies that are just a simple expression? And so we want to allow that. We don't yet in this prototype, so you see a lot of red there. But this should really, why shouldn't a function just look like this, right? And so we again, inspired by functional languages and more expression-oriented things. And self, yes, very deeply inspired by self. You can do that. Properties, again, a lot of people have getter-only property. Again, if you want to be an immutable type, you're only going to expose a getter. So, and again, the getter body here is a return thing. So we just want to go all out and say a property. You don't even have to say that it only has a getter. You can just do like this and express that this is a computed property. The value, every time you call it, the value is computed with this expression. So just getting to look more like other nicer languages. I'm really not claiming that there's something new here. It's just like we're we're giving it a good facelift, and that's kind of our approach here. I want to show a few things that are a little more on the sort of new and crazy/interesting end of the scale. Let's look here at a method that takes, an array, a JSON array thing, and turns it back into a list of points. One of the things that is really useful, moderately useful in C# is that it has out parameters that you can pass in a variable to a method. The method will fill up the variable with something, and when the method returns, the variable has that content, right? Like good old out parameters in Ada. Where else do we have out parameters? It's actually pretty useful. We have this try pattern where you call something. It's good for when you have more than one result, right? There's this pattern you call try get this, try get that, pass in an out parameter to get the value out if it was there, and return a Boolean to see if it worked out. The really annoying thing about out parameters is you have to pass in a variable, and in order to pass in a variable, you have to declare a variable, and you need an extra line for that, and so on. And so you kind of want to just declare the variable as you go along. And so the really weird feature that we're adding to C# is the ability to declare, is what we call a declaration expression, the ability to declare a variable inside of an expression. So you can just say int x or int y right there where you need the variable. It doesn't have to be for an out parameter. Anywhere where you want to gather up a variable for some reason inside of your expression, you can just declare it. It has a reasonable scope. Say in an if, you want to do a type test, and if you check if converting to that type means null. If it does, then you grab up the value and you have it in scope for your if. So little things like that. And
does that mean you can use them as like temp properties?
Does that mean that you can use them as temp properties?
Well, essentially like temporaries inside.
Yes.
Yeah,
exactly.
They're just like other local variables, except you get to introduce them in the middle of an expression and use them a little later in that expression or in a subsequent.
Yeah, it's going to be great for like just generally code obfuscation if you want to write a really large expression to put everything and assign it at the very end.
If you want to go all out on, I'll get to you in just a second. I got you noted. If you want to go all out on being expression-based, it's really nice to be able to get rid of extra lines of statements. I actually have a version of this method that is one single expression. I'm not going to type it, but I'm going to desperately wait for my toolbox to come up with it. It's not going to do that, is it? Every time I present the toolbox,
gone, man. It's not
gone.
There.
Okay, so you can type. You can, because you're reducing the set of statements here. You can kind of turn this all into a BigQuery expression, and it's all like kind of very overly functional, and all because of inlining things like that. So let's have the question over there.
So are X and Y in scope in the else branch?
Are X and Y in scope in the else branch? Yes, they are. Yes.
They're in scope from that point forward within that block there.
They're essentially in scope within a containing thing, which is typically a block. Or we can get into scope. You can read about scope rules. But yes, they're in scope in the else branch as well if you have one. Because I mean, we might as well have said if not here, and then the else branch is where we would want the values. So we don't try to reason about which of the branches it should go in.
It would be very restrictive otherwise, right?
So may I suggest to make those immutable, like Smalltalk did with function argument variables?
So, make the declared variables there immutable?
Yeah. So once the called function sets them, you don't get to change them again afterwards.
That is a good idea. We'd probably want like a separate notion of that kind of variable, even for when they're declared as statements, and give that a different syntax.
It was handy in Smalltalk. Arguments you could not change assigned to in the body of the function.
Point taken.
Making it not work that way was just one line.
So that's yet another little small weird thing there. I want to also show another one that you can't use it, but I can use it. I have a slightly different build here, which is also a stolen feature. It's the sorry.
Sorry, in the previous one, do you have to specify the type?
No, you can use
actually you can use. So that's a good question. We generally let's find it again here.
Repeat the question.
Okay, do you need to specify the type? So generally, we have in C# that if you initialize a variable, you don't need to specify the type. So you could say this was equal to 7, and then you could just, if you had an initializer, you can just say var. And you can certainly do that here as well. But we also, in the case where overload resolution can easily find which surrounding method it is, we will just look at that method and see, oh, it expects an int. So let's just infer int. So even in the case where you don't have an initializer, we'll just infer from the callee that the type that this variable is supposed to have is int and grab it from there. So we've been smart enough about that, I think. Yeah, more questions. Wow. Yes, I just want to watch the time. What's that?
Do you need var there? I mean,
Well, it already has a meaning, right? If it's,
yeah, the problem is otherwise it means reference another variable that's already in scope.
Yeah.
So you need something to call out that it's a declaration. We're kind of shot there. Actually, Visual Basic lets you do this and not put anything, and they'll use a variable if it's in scope and create a new one if they're not. But, we kind of have a different philosophy.
Let's see.
Was that your question?
Yeah, question. So the declaration expression you had there as part of the out argument, could you just use it in any expression?
Yes, you can use them in any expression. They're just a new kind of expression. Okay, so I just used this as a motivating example, but you can do it like when you find yourself computing the same thing over and over inside of an expression, you can just grab it the first time into a variable and then use that variable for the remaining part of that expression. And of course, you can just declare it on a separate line most of the time, but sometimes you're actually in a context, like when you're inside of a query expression, other places, you're in a context where you really have to be an expression. You can't be a statement. And so this introduces new possibilities. You can actually now declare variables in the argument to a base constructor, right? You couldn't do that before because that needs to be an expression.
Right.
You can declare them in initializers for variables, for fields if you want.
Again, the code obfuscation technique.
You can obfuscate a lot of things. So that
you can do a lot with it. It's very powerful.
If you don't meet the value of the return value, you can always just have a statement without assignment. Can you just leave this as null if you don't put it in that variable?
I mean,
if you have out parameter. But you
for out parameters, could you just pass in
just null everything?
just null? Yeah, so this is kind of a half solution to a problem that people have when there are many out parameters that they say, I don't care about this particular result. Why do I have to pass something? And before you had to declare something on a separate line, then pass it just so you could ignore it. Now at least you can declare it and ignore it in the same field swoop. So it is an improvement. It is maybe it would be nice to have a syntax for just saying, ignore this particular out parameter. I don't care about it. We don't have that syntax. That's a great suggestion. We'll take that. Now we're a step closer, so that might be within striking distance now. I will take one more question now, and then we'll go on a little bit.
So kind of in the realm of, since we're talking hypotheticals here, right, what could be. Out parameters are just one way of handling the fact that you're returning more than one thing.
Yes.
Integrating maybe tuples more closely with the language would be another mechanism to do that.
Yes.
Has that been thought about? Is that?
Oh, yeah.
Yes. So let me repeat the question. So there are many ways of getting more than one value back from a method. One of them is tuples or other kinds of record or compound structure somehow. And we have looked at that some, and we're thinking about whether tuples are the right thing, or whether we need some other kind of structure for that, whether we want some kind of pattern matching related to that. Like, do we want to take C# in a direction where it essentially allows full-on pattern matching on classes? Maybe they declare how they want to be matched, or maybe that primary constructor on there somehow indicates what kinds of things you can match back out of a given class, stuff like that. Maybe there's something there. We've decided not to go down the road for this version, but hey, so this is a version in flux, but that's probably out of scope. But we might do that a little.
To answer your question, yes, we've thought about it.
Yes, we thought about it. No, we're not going to do it yet.
I asked only because the general direction
Yes.
has been to have more functional style features
Yes.
to the language.
Yeah, and that's sort of the more functional style is sort of the overall theme here, as you see. And yeah, maybe someday. One problem with out parameters, for instance, first, it's not really symmetric. Like you're giving one return value special status over some other ones. But another one is for asynchronous methods that return task of something or return futures. You can't return out parameters from those. And so at least we don't know how to implement that. And so there are other ways in which it's limited. So anyway, that's a good point. I just want to show the null conditional operator that we're also putting in, which is, when, if you're worried that something is null before you dot it, instead of having to test first and so on, we want to allow you to just say, question dot, get the do the subsequent list of dotting here, so kind of make it short-circuiting so that only happens if the thing was not null. Otherwise, the whole thing becomes null, right? And so if I go through calling with these different people here, the third one being null, we wouldn't even call first name and length on it. The whole expression would just evaluate to null instead. You can also do it for, oh, I didn't mean to erase that much. You can also imagine doing it with indexes. So I could say question, give me the 0th element if first name was not null. Also, it makes a difference whether you put dot here or whether you do question dot again. Like, can first name be null or not? If I think it can never be null, well, I wouldn't put the question mark, but maybe it could. Maybe Tony Hoare, who invented the billion-dollar mistake of null pointers, according to himself, maybe we should give him a null first name. And then we would have to, if we did this, even though Tony Hoare would be there and we would check for him not being null, we would still crash when we try to access length of with his null first name. But we could guard from that by putting additional question marks there. So I'll take one more question. Yeah.
Can't help notice that you have the first question mark, so it could return null, but length is a value type. So would it go to a nullable?
Yeah, so then it will go to nullable value types, which we happen to have lying around in the language as well. So that actually works out well. And we also have the null coalescing operator, which is already in the language, that says if the left-hand side is null, use this value instead. And so you can kind of pull it back to int instead of int question mark in this case by giving a default value like that. OK, so we're out of time. Great questions, and I showed a semi-random subset of what we're already planning to do. Please engage if you're interested in C# on CodePlex, or email us, or take the language for a spin, take the compiler API for a spin, and let us know what you think. Thank you very much.
Yeah.